The Department of Water Resources is still releasing water from the Oroville Dam. The total releases from the spillway are 15,000 cubic feet per second.
On December 19, 2:17 a.m., Lake Oroville quietly began a transformation that would terrify engineers, alarm scientists, and unsettle thousands of residents. No storm clouds hung above the Sierra Nevada mountains. No upstream reservoirs released emergency flows. Yet, in the darkness, 7 billion gallons of water surged upward, swelling the lake by an astonishing 23 feet in less than 4 hours. This was not a rainfall anomaly. It was not human error or routine fluctuation. Sensors went into overdrive at 2:17 a.m., alerting technicians to readings that defied physics. By sunrise, the shoreline had receded 60 feet inland, and benches that had long sat high and dry now rested completely underwater. The chemical makeup of the water only deepened the mystery. Unusual lithium, boron, and rare earth metals indicated that the water had not fallen from the sky. Instead, it had surged from deep underground, pressed upward by forces no one fully understood. And beneath the calm surface, seismic monitors detected tiny quakes, precisely as the lake began its inexplicable ascent. Lake Oroville is more than a lake. It is a lifeline, the central artery of California's water system, feeding millions of residents and irrigating thousands of square miles of farmland. To witness this reservoir rise without explanation is to stare at a ticking clock, a reminder of how precariously humans balance on the edge of nature's power. Chapter 1. The Silent Surge. Technicians first noticed the anomaly on the east side monitoring station. At 847.3 feet, the lake seemed ordinary, but within minutes, readings skyrocketed. 848, 850, 855, and by 6 a.m., 870.1 feet. A 23-foot gain in under 4 hours had no precedent. Engineers cross-referenced data from 3 independent systems. Backup sensors and manual measurements confirmed the surge within 2 inches. This was not a computer error. Lake Oroville had risen in a way no one could explain. Field crews arrived at the shoreline to witness a scene that defied emergency protocols. Intake towers, normally surrounded by exposed rock, were now lapped by waves. Buoys floated in positions that contradicted navigation charts. Park benches 10 feet above the surface were fully submerged. Upstream reservoirs were stable. The Feather River remained flat, and satellite imagery showed no visible debris or displacement. The sudden rise had eliminated every normal explanation. No rainfall, no upstream releases, no landslides. The lake itself had become the mystery, and the world downstream held its collective breath. Chapter 2. The Human Toll. For residents like Maria Santos, the rise of Lake Oroville was more than an abstract statistic. She had lived through the 2017 Oroville Dam crisis, when the spillway nearly collapsed, forcing 188,000 people to evacuate in chaos. Traffic jams, separated families, overfilled shelters, and the sound of sirens at all hours had etched trauma into the memory of the community. Now, as she watched the lake claim another foot of the shoreline, memories came rushing back. Her neighbors' wooden docks, once centers of summer gatherings, were fully submerged. Roads leading to the marina were turned into slurry-filled barriers, isolating lower neighborhoods. Distrustful of official updates, Maria began her own preparations, methodically packing family heirlooms, photo albums, and vital documents into waterproof bins. Trucks stayed fueled and ready. Children knew evacuation routes by heart, and go-bags lined the mudroom. For many living near Lake Oroville, perpetual readiness had become a necessity. The lake's inexplicable rise had turned calm homes into fronts of silent anxiety. Chapter 3. The Science of the Surge. Investigators quickly turned to chemistry and geology for answers. Initial water testing revealed lithium levels 4 times higher than normal, boron spikes consistent with deep geothermal sources, and rare earth metals indicative of prolonged contact with bedrock. Isotope analysis confirmed the water had not come from precipitation in the Sierra Nevada. It was deep underground, ancient, and pressurized. Seismologists reviewed 48 hours of earthquake data and discovered a pattern. A cluster of microquakes occurred beneath the eastern section of the lake, precisely when the water began rising. These quakes, imperceptible to humans without instrumentation, may have opened rock fractures connecting deep aquifers to the surface. Just fractions of an inch of crack expansion could allow billions of gallons to surge upward. Yet critical questions remained. Where exactly was the water entering? How long would the flow continue? And were these events linked to a vast, unmapped underground reservoir system? Scientists can only measure what reaches the surface. The underground remains a mystery. Chapter 4: Piping and Structural Risk. Beneath the calm exterior, another invisible threat lurked: piping. Water could carve tiny pathways through soil or concrete, gradually widening channels over time. By the time external erosion becomes visible, internal damage may be catastrophic. During emergency inspections, engineers found cloudy water emerging from drainage systems embedded in the dam foundation. Pressure sensors indicated anomalies not seen since the 2017 crisis. These readings mirrored patterns observed in catastrophic dam failures worldwide. The Teton Dam, Idaho, 1976, which killed over 2,000, Italian dams where early warning signs were ignored, and Uzbekistan's 2020 dam failure. An independent engineer installed high-frequency hydroacoustic sensors and pressure transducers along the concrete and deep foundations to detect any internal flow. But scientific verification takes days, while the lake, governed by gravity and underground pressure, continued its relentless ascent. Chapter 5: Theories of the Unknown. With no definitive cause, speculation ran rampant. 1. Ancient underground reservoirs. Some hypothesize a prehistoric aquifer sealed deep beneath the Sierra Nevada, finally releasing water due to microquakes. Mineral and lithium concentrations support this theory. 2. Human interference. Rumors of secret military tunnels or industrial drills penetrating high-pressure underground rivers suggest the surge may be artificial. Unmarked vehicles have been spotted near turbulent lake areas. 3. Volcanic pipe hypothesis. Heat signatures in water samples suggest magma pockets may be shifting miles underground. A volcanic piston could be pushing groundwater upward, transforming Lake Oroville into a vent for deep subterranean pressure. 4. Hollow Earth speculation. Local forums speculate giant pockets of water exist miles below the surface, held in precarious geological balance. A sudden fracture under the lake could act like a balloon popping, forcing ancient water to erupt to the surface. Each theory contains elements of plausibility, but also profound uncertainty. Lake Oroville's rise is a stark reminder of how little humans understand about the subterranean world. Chapter 6: The Ecological and Economic Impact. The surge is not just a scientific puzzle. It affects life, land, and livelihoods. Turbidity rises as sediments churn, suffocating salmon eggs and disrupting ecosystems. Mercury and lead from historic mining operations resurface, creating invisible hazards. Economically, Lake Oroville is central to California. Water from the lake irrigates the Central Valley, supports Napa and Sonoma vineyards, sustains dairy and produce farms, and supplies more than 27 million residents. Hydroelectric turbines generate power for 800,000 homes. Every foot of water movement represents billions in economic impact. A dam failure would not just flood local communities, it would cripple agriculture, energy production, and water security across the most populous state in America. Lake Oroville is, in essence, the beating heart of California. When it acts strangely, the entire state and beyond feels the tension. Listening to the lake. As Lake Oroville continues to rise silently, scientists, engineers, and residents are left asking the same question. Is this a natural miracle, a long-awaited reprieve from drought, or a harbinger of catastrophic failure? The lake reminds humanity that control is always an illusion. Nature exerts power in subtle and sudden ways, often when we feel most confident in our mastery. Behind the concrete walls, billions of gallons press upward against 50-year-old infrastructure, testing the limits of engineering and patience. For residents like Maria, and for millions depending on the lake's stability, preparation is the only certainty. For scientists, every measurement is a clue to an invisible puzzle stretching miles below the surface. For the world, Lake Oroville is a warning. The forces beneath the earth are ancient, immense, and often unpredictable. Will this surge end peacefully, providing water where it is desperately needed? Or will it mark the beginning of a crisis, a reminder of humanity's vulnerability in the face of geological power? Only time and careful observation will tell. Until then, the lake rises and the world watches. Stay informed, stay prepared. And if you want to keep learning about the world's most hidden dangers, like this video, subscribe and hit the notification bell, because the next disaster could be closer than you think.